Today we are going to be adding numbers in different bases using base block model, a traditional algorithm, and the lattice addition. In this problem, it is important to know that one unit is represented with a dot. A rod, which will be 8 units, is represented as a stick. And then a flat, which will be 8 rods and 64 dots, will be represented as a square. When adding this together, we will start with dividing 53 into one of these numbers. We will start with 8 because 53 does not go into 64. So we will start by 1, 2, 3, 4, 5, 6 rods, which equals 48, 49, 50, 51, 52, 53. So this will represent our first number. And then for 76, we know that 76 divides into 64. So we will have one flat. We will have one rod bringing us to 72, 73, 74, 75, 76. Now when adding these together, we know that 8 units equals 1 rod and that 8 rods equals 1 flat. So let's count them out. We have 1, 2, 3, 4, 5, 6, 7, 8. So 8 of these will equal 1 new rod, leaving you with 1 dot left over. Now if you add up our rods, we have 1, 2, 3, 4, 5, 6, 7, 8, which equals 1 flat. So we will take all of these and turn it into a flat, and then we have 1 more flat left over. So following this base block, we will use 2 flats and 1 unit. We can check this by adding the flats and the units together. When adding, we are still adding in base 8. So we know that our highest number that we can go to will be 7. So we have 8 here, which will actually be represented as carrying over. 1 plus 1 will be 11. And then we will do 6, 7, 8, 9, 10, 11, 12, 13, 14, up to 15, equaling 151. We know that we can check this by adding it the traditional way. So you have 6 plus 3 equals 9, which will actually bring you up here, bringing down your 9 as a 1. And then you will add the 7 plus the 8, which will equal another 10 plus 5, which will equal 151. 151, 151, 151. Moving on to our next problem, your traditional algorithm. In this problem, we are using letters to represent numbers. So you will go to what the number represents on the letter line. So A is the first letter, so that equals 1. C is the third, so that'll represent 3. And F is the 6th, that'll represent 6. So with our new numbers, we have 313 plus 896 and base 16. Knowing that this is in base 16, we know that your highest place value will be 15. So adding this down, you will have 9, 10, and 11, giving you an answer of 11,109. Now to move on to our lattice addition. In our lattice addition, we are going to be taking our place values, and instead of distributing our numbers up at the top, it's going to be in columns going diagonally. Plus 204. All right. If you add 1 to 4, that equals 5, which is our whole number. Now you'll add 4 plus 0 is 4. And then you'll have 3 plus 2, which will be another whole number of 5. So now you will add the columns diagonally here. 0 plus 0 is 0. 1 plus 4 is 5, giving us our whole number. You will have 1 plus 0, which equals 1, and you're left over 1, giving you a number of 1,100. We can check this in our traditional algorithm, distributing the numbers on the top. So we'll have 5, 5, and 11. 1,100, 1,100. Now we are going to move from addition to subtraction. For our traditional method, we are going to do 341 minus that'll actually be 342 minus 243 in base 5, and your traditional algorithm of 72 in base 8 minus 36 in base 8. When using these for base blocks, I will write out my numbers like this. So in this problem in base 5, we know that 1 unit is represented with a 0, or with a dot. We know that your rod will be represented with a 5, and we know that a flat will be represented as 25. We have 5 dots equaling 1 rod, and 5 rods equal 25, or the 25 for 1 flat. So for this one, we know that we have 3 flats. We have 4 rods and 2 units. Now if we subtract 243, we know that we have 2 flats, we have 4 rods, and we have 3 units. All right, so off the bat, we already need to borrow because 2 can't subtract 3. So we're going to come over here to our 4s. We know that one of these rods is equivalent to 5 units. So what we are going to do is borrow one of these and put it over here, making this now 3 rods. So now you can subtract 5 minus 3. Leaving you with 4 units. Now to come over to this place value, we now are subtracting 3 from 4 because we borrowed one of our rods to turn it into units. So we cannot take 3 away from 4, so what we need to do is come over here and borrow from our flats. We know that 5 rods equals 1 flat. So we are going to take away a flat, turn it into 5 rods, and we are going to borrow this rod and bring it over here. That is going, so you're going to add the rod, which will be 5, now turning this into 8. Your new number you'll be subtracting is 8 minus 4. So if you take out your 8, you will be left with 1, 2, 3, 4, 5, 6, 7. You will be left with 4 rods. Now coming over to our flats, we still have 2 flats and 1, 2, 3, 4 rods. So what we're going to do is subtract the 2 rods, or the 2 flats, and what you'll be left with is 1, 2, 3, 4 rods. For a traditional algorithm, we're going to come over here and do 72 in base 8 minus 36 in base 8. We know that you can only go to the number 8 with it being in base 8, so that's something to keep in mind. While doing this, we are going to have to borrow from our 8th place value again. So what we're going to do is take away from 7, turning into 6, and because we borrowed 1 whole rod, that means that we're going to have to add it over here, which will be 8. 8 plus 2 will now make this 10. 10 minus 4 or 10 minus 6 equals 4. And then coming over here, 6 minus 3 is 3, making it 34.